Hi, my name is Skunbut A with Tianipon, and this is lecture 5 of Probability and Statistics for Digital Artists. Today we are going to learn about probability. What exciting? Okay, let's start with some terminology because this is gonna be most of the topics here is gonna be confusing when if you talk about probability in in any aspect any areas. And the problem here is when we talk about how to take samples, how to randomize, how to choose stuff. And we usually talk about different things using different words. So let's first settle the formal words we use in these topics. So when you randomize, you usually think about these 4 steps, and we're gonna use this for methods of randomizing a lot in this class. So we have a dice, and a dice has 6 sides. Right. Usually when I say a die, and by the way, die is a singular form of dice. It means when I say a die, we almost always assume it's 6-sided, the standard one that we use. But if it is necessary to specify which, I will use the word 6-sided die. We have dice, we have cards. And when we talk about cards, we think about the standard poker cards where there are 52 cards, and each card has one of the suits, which are heart, a diamond, a spade, or a club. I have taught this class many times, but I still cannot draw the card well. Oh, and there are faces. We have S, 2, 3, 4, 5, 6, 7, 8, 9, and J, Q, and K, like Queen and King. And each we can form a pair of face and a suit. Let's say the suit has a face. And then there's a card for each pair. For example, you can get a card of 8 of spades. For example. And so that's the standard model of cards we use. And we have a flip, of course. We have a coin. A coin has 2 sides, and we're gonna represent each side as either a head or a tail. And sometimes the coin would land on its side. Yeah, but let's ignore that for now. Let's say it's only head and tail. And we have a lottery. In this class, since we are in Thai, whenever we say a lottery, or be precise, lottery tickets, then we think about the standard 6-digit number that can start with 0. And so these are what we usually have in mind when we think about random. And these are all we need to think in the life of usual people. But of course, when you start to use those things in games, they take different forms. And when you think about die, a die in game, you can have more than 6-sided. It's 10, 8, 12, 30, 20. Or it could be like, just this comes somewhat equivalent to picking balls of various numbers from a box, and then you can model those balls in any terms you use in your game. Right, so these are what we think about. What we think of when we say the word random, right? But then what is actually random? Like what would you call them when you perform something, you do something? Like for a die, you use the word draw. For a card, you use the word draw. For a coin, you use the word flip. And for a lottery, you use the word what? Buy or something. Anyway, so let's settle on the word used. So there are 4 main words here, right? Whenever you perform some kind of randomized event, then there are actually 4 words. 4 different vocabulary you need to learn. First, it is an experiment. An experiment is just any operation you carry out. And so first, whenever you want to randomize something, you have to first explain clearly what you are doing. Maybe an experiment could be like to roll a die. And this is an experiment. Or flip a coin. Or draw a card. And for the lottery, maybe you buy, I don't know, buy a lottery ticket. Right? So first we have to be clear what we are doing here. And then once we perform that experiment, right, then we have 3 more words to talk about. First, we have an outcome. So it's a result of an experiment. If you roll a die, what could be the possible result? What would be possible results? You can get, you know, a 1 or a 2 or a 3 or a 4 or 5 or 6. That's the usual die supposed to be. Okay, maybe you should get some die. Right. Oh, if you don't want to, you know, draw the face, you could actually use the numbers instead. And of course, that is what we are going to use. And so represent the result, an outcome of the experiment as a single digit, single number from 1 to 6. And for a coin, you can the basic the standard model is to represent an outcome as either an H, a single letter, or a tail. Or sometimes it may be more convenient to use 0 and 1. If you know how to code, if you are in the programming part, then you prefer that. And you know, just make sure you describe that. And then 2 more words for an outcome. First, we have the sample space. The sample space is a set. The set. Now we talk about the set. The set of our possible outcomes. And so whenever we talk about the sample space, usually we use the capital letter S to represent the sample space. And then you have to include all the outcomes here. You could, of course, describe the set as in the, let's say, as a description. It's a set of all outcomes such that X is an outcome of an experiment. I didn't actually present that in the previous lecture that we have, but so. So this will be the description. And it usually, if there are not too many outcomes, we would just describe the elements and write them explicitly. For example, if you roll a die, that sample space with a set of these numbers. Like this is a sample space of rolling a die, and that should be blue. And let's say if you can change the color. Oh. Alright, what about the set of the sample space of this of an experiment of flipping a coin? It will be the set. There are 2 outcomes, and those are the outcomes. Yeah, if you draw a card, and get, let's explain that as in this notation, the face and then the suit. The face followed by the suit. Yeah, we have ace of heart, we have ace of diamond, we have ace of spades, we have ace of clubs, and so on and so forth. That's a simple space. And finally, this is the most important part that we're gonna use a lot. Is an event. An event is any combination of outcomes. So we have two keywords, and you have outcomes, and we have combination. So when we talk about an outcome, it is a single outcome, but an event can be any combination of outcomes. Or maybe better. It is better to describe in terms of set notation, which is a subset of the sample space. And so, for example, if this sample space, if you talk about the sample space of rolling a single die, right, an event, let's say A, could be it's a subset. Let's say we just take the odd even numbers. And this now is an event. It's a subset. Or it could be it could just include just a single element, just a single outcome from that sample space. This is also an event. You know, it could include everything, because its set is a subset of itself by the definition of a set. Right? Or it could include nothing. This is also considered an event. It's other subsets. And the thing is that it looks clear here, right? Okay, just you pick some elements out. But usually the event is described or is given to us as a statement or a sentence. Then you have to transform that sentence right into the set notation before you can work out the math. And so for example here, I actually did that. So use this for terminologies to describe rolling a single die. And so what is an experiment here? It is of course just you roll a die. That's it. It is clear enough here. What could be an outcome? Let's say 2. The 2 is an outcome of rolling a single die. Note that we talk about just any outcome. We are not being asked about to give the complete list of outcome. The complete list of all the outcomes is in the sample space. Right. So here, if you are asked to give a sample space, you have to write it as a set and give it a name as a set of all possible outcomes. 1, 2, 3, 4, 5, and 6. And finally, what would be an example of an event? Let's just say, you get 6, for example. Or get either 1 or 6. Because those are the two extreme ends when people think of the words lucky or unlucky. And so here, that's what it's terminologies we use. Right, so we have this for terminologies, and next we have more vocabs. Now we are getting to the main meat of this topic, which is the probability. Okay. Before we go, we're gonna go to do some math. Then let's step back and see how this word is defined. And so the probability is a measure. Okay, when we think about measure, we think about what could be a measurement. A ruler. Let's use that ruler to measure something, or a scale to measure the weight of an object, or we could get a clock to measure time. And a probability is also a measurement. It's hard to think of a single object, right? But it is similar to these things. Right? What does it measure? It measures this measurement is associated with how certain. Okay, that is it's measured the certainty. When we measure the length, we think of an object as short or long, and if you just use simple vocabs. If you think about a weight, you can think about something that is either heavy or light. If you think about time, you can think about something that is fast or slow or long and short. Right here again, in probability, it's also measure the certainty, and the true extreme ends of the certainty is we can be certain or uncertain. Right? This is what this thing that is trying to measure, right? What certainty of what? Of outcomes of a particular experiment. And now you can see we have two words that we just defined. And so before we go to again, before we get into the math, the numbers, let's compare our intuition to the actual definition. We have two extreme ends. We have in here we measure the measurement is between 0 and 1, inclusive. It can be 0, it can be 1. So you can think of a scale right? And then the probability is any number between these two numbers. Right? On one end, on the 0 end, right? It means we are certain that it's never gonna happen. Can you think of an outcome that never gonna happen of some experiment? For example, if you roll a die, right, you are sure that it's never gonna give you a 7, unless you do something about it. That die, you know there are six sides on this die. Yeah, there are numbers 1 through 6, so it's never going to show you a 7. It's obvious here, but maybe if you can it show a number that is like, you know, higher than 5, okay, higher than 8 or something. Again, that event is never going to happen. Or if you flip we will see that later. Right, on this is on the end, like the 0 end. On the other end, like the other extreme end, the number 1. This is describing an event and an outcome that is surely going to happen. We are sure we are certain that it always happens. For example, if we go back to the dice example, right? If we ask how likely that when you roll a die you get a number smaller than 10, for example, right? Since you know all the faces of the die, it's 1, 2, 3, 4, 5, or 6. That means it's always going to give you a number smaller than 10. Okay, so you are certain it is guaranteed to give you the outcomes that you want. Okay, so this is the one side, and everything in between is between these two, right? Between the never and always. And I mean, we have a lot of words to describe the position or our perception of that something is wrong with. And in English we have lots of words, right? This is never, this is always. Maybe you have some word like sometimes. It sometimes happen, it's sometimes not happening. Well, we have the words, maybe we have the word seldom or rarely. Sorry about my handwriting. I should rarely, like all the word often. Yeah, we have often or usual. Right, this word doesn't give you an exact number, but you can have a sense of where it lands on this scale between 0 and 1. Right, so that's the definition of probability. Right, and then the question is, how can we get an exact number? If you just try your experiment, you give me an event. Like this is an event that you want. And then you ask what is the probability that the event occurs. Then now we are doing the math. And before we go to do some more fun math again, let's add 2 more words. We're gonna have some easy, let's say the easy part. Right. The first word is equally likely. Equally likely. Then when we talk about something that equal, right, I mean they are the same. And then since we are talking about the likeliness, is the event going to occur or not? Then the equally likely, like this word describes the probability of an outcome. So if we have an experiment, and that experiment has a list of outcomes, have a sample space, and if that experiment is equally likely, that means that each outcome of an experiment occurs with equal probability. So if you have 2 coins, like head or tail, if they are equally likely, that means the probability like to get a tail and the probability to get a head, right, they are equal. Right, we're gonna use that word later. Like, or if you have a die and there are 6 sides, how did I skip 5? 4 and then 5 and then 6. That means each outcome of this experiment, each element in the sample space have the same probability. Whatever that number is, you will see that number in a moment, right? And then we have the word fair or biased. Right? When we talk about equally likely, we talk about an event, right? Or we talk about an outcome. Right? But when we talk about fair or biased, this is a property that belongs to a randomizer, the object or the process that we use to randomize. In this case, we think about a die, a coin, or a card. If they are, if a die is fair, it means each outcome, all outcomes are equally likely. If a coin is fair, it means both outcomes, head and tails, they are equally likely. If it is a card, it means all 52 cards are equally likely to be an outcome. And we are now we are ready to give let's say a first theorem. If there are n possible outcomes and they are all equally likely, then the probability of each outcome is 1 over n. And this is the, let's say, what's the word? Everyday person would understand this theorem. If there are 2 sides of the coin, and each side should have about like 1 over 2 or 1/2 chance to occur, to happen. If there are 6 sides on a single die, and then the probability that a specific side shows up is gonna be 1/6. And this is what we should think about probability, the easy case. But the keyword here, you have to be careful that the keyword here is equally likely. This is where people fail to realize when you encounter a new problem or an unfamiliar events, right? Unless if they are equally likely, then each outcome is 1 over that number of outcomes. But if they are not, then we cannot just say 1 over 6 or something. Like there are like memes that okay, if there are only 2 outcomes, like if it either fails or success, right, then it means we have about 50-50. And that's the word 50-50. That's where the word 50-50 comes from. It's 1/2 and 1/5. But that's not always the case, right? Because you can see that the probability of failure and the probability of a success doesn't need to be equal. Like more people fail, there are more people who fail than people who are successful or people who succeed. Right, so that this 1 over n only works when they are equally likely. And this is what you have to state beforehand.